So 14 years ago, if you wanted to charge a customer credit card on your website, here's what your Tuesday looked like. You would call a bank, not sign up online, call. A human being would ask you to fax over your business license, your last 2 years of financials, and a written explanation of what exactly you were planning to sell. And then you would wait 4 weeks, sometimes 8, and then if you passed underwriting, someone would email you a 200-page PDF of an XML documentation for a payment gateway built in 2003. And if you got the integration wrong, your customer's card number sat exposed in your own database, which meant you are now personally liable for a security audit that most Series A startups couldn't afford. That was the entire internet economy. Every checkout button, every subscription, every marketplace gated behind 6 weeks of paperwork and compliance nightmare. Today, that same integration takes one developer about 4 minutes and they will never speak to a human to do it. That shift from 6 weeks to 4 minutes, it's worth about $400 billion. Most people think it happened because Stripe made a nicer firm. They did not. They rebuilt the plumbing of the internet economy underneath it. And they did it with 3 specific engineering decisions that most companies are still too scared to copy. Because copying them means giving up control, and I'm going to show you the actual code. So here's the mental model for the next 25 minutes, and I want you to hold on to it because everything else is just this idea applied 3 different times. So old financial infrastructures treated risk and code as the same problem. If you wanted to reduce risk, you added more paperwork, more humans, more friction, which meant more code, complexity downstream. What Stripe's actual innovation, the one nobody puts in the pitch deck version of the story, was separating those 2 problems entirely. They absorbed the risk themselves at the company level so that the code could stay radically simple. Every architectural decision you are about to look at, how their API never breaks, how they stop you from double charging a customer, how they split a single payment across 1,000 sellers, is the same move over and over. Swallow the complexity internally so the interface stays a straight line. Let's start with the one that should be architecturally impossible. Here's a sentence that should not be true. An integration a developer wrote against Stripe's API in 2011, the year the company was basically 3 people in a room, still runs today. Untouched, no maintenance PRs, no depreciation emails, it just works. 13 years later, against an API that has been rewritten underneath it dozens of times, okay? So if you are ever maintained a public API, you know why that's insane. Every other platform on earth solves this with version numbers in the URL, V1, V2, V3, which really means you are going to break your code and it's your job to keep up. Twitter did this. So did half of the enterprise SaaS tools you have used. Miss migration window, your app goes dark. Stripe never versions the URL. It's always V1 forever. Instead, look at this one header, okay? Stripe version. That's not a software version, it's a date, the exact day this developer's account was created. And Stripe made a permanent promise on that day, whatever the API looked like at the moment is what this account will see forever. Like even with the real API, the one every new developer hits keeps evolving underneath, right? So here's the question that should be bothering you right now. How do you keep rewriting your core product for 13 years straight without even touching thousands of integration frozen in the past? 3 layers. Let me walk you through each one because this part almost nobody explains correctly. Layer 1, a request comes in from an old pinned account. Before it even touches the Stripe's real product code, a translational layer intercepts it and rewrites the old format request into whatever the current schema expects. Layer 2. And this is the part I actually respect the most, the core engine. The actual product code every engineer at Stripe works in day to day has zero knowledge that old versions even exist. No. If year is less than 2018, conditionals scattered through the code base. No historical baggage, the engineers writing new features are working against a clean current schema, full stop. That's it. Layer 3. The response comes back in a modern format, and on the way out of the door, it passes through a chain of tiny isolated transformation modules that walk it backward through the history, and one version at a time, until it lands back in exactly the same shape that 2015 account is expecting. Look at this. This is one real transformation module. Modern Stripe stores a customer billing address as a structured nested object. Street, city, all separate fields, but a 2015 Paint account expects one flat string. 123 Main Street, San Francisco. This module does exactly one job. Takes a modern shape, mash it into old shape, hands it back, that's it. Doesn't know about any other version, it doesn't care what happened in 2016 or 2020, it's a single dumb reliable brick. And when a request comes from an account that's 3 versions behind current, the system runs 3 of these bricks back to back. 2024 shapes become 20, shape becomes 2016, shape become 2011 shape. Finally, it's just a function composition. Apply transform after transform after transform, left to right, until you hit the version the client is pinned to. It looks like intimidating math on a whiteboard. In practice, it's Lego bricks. Here's what that buys them. And this is the actual business hiding inside the engineering. Every other API platform trades developer trust for internal cleanliness. They keep their own code base simple by forcing you to migrate. Stripe made the opposite trade. They accepted permanent internal complexity, an ever-growing stack of these transformation bricks, and in exchange for a promise they never have to break. Your integration will never wake up broken. That promise is worth more than almost anything else they would have built, right? Because the moment a payment API becomes something you have to babysit, you start looking for a way out. Stripe made sure you never had a reason to. Picture this exact moment. A customer clicks pay $50, the request hits Stripe servers, the charge succeeds, money actually moves, Stripe sends back a confirmation and the confirmation never arrives. Maybe the customer's Wi-Fi drops for half a second, maybe a router somewhere hiccups from your application point of view. It is total silence, no errors, no success, just nothing, right? What does your code do next? If you are like most engineers, your instinct is retry the request. Send it again, seems safe, right? But it's not safe. It's how customers get charged twice for a single purchase. This is one of the oldest, nastiest problems in distributed systems, and it has a name: ID impotency. Can you safely repeat an action without it happening twice? Stripe's answer is a single HTTP header. Before your code sends any charge request, it generates a random unique ID and UUID and attaches it as the header. Not at the amount, not at the customer, just a random fingerprint that says this is attempt number 1 of the specific action. If the confirmation gets lost and your code retries, it sends the exact same key, and here's where it gets interesting. Stripe isn't just checking, have I seen this key before, yes or no? They are running a small statement machine underneath. The very first request arrives, and the system does something clever. It writes, I am processing this key, and commits that write in the exact same database transaction as an actual charge. Not 2 separate steps that could fail independently. One atomic move. This is one atomic move. Either both happen or neither does. Now, 3 things can happen next. Each one tells you something about how seriously they have thought about failure. Scenario 1. The original request actually succeeded, but you never heard it back, so you retry. Stripe sees the key is marked completed and just hands you back the exact same response it generated the first time, without you touching the ledger again, right? So you get your confirmation, the customer gets charged exactly once. And scenario 2, and this one is subtle, of course. What if 2 retries fire at exact same instant because your client has aggressive retry logic? Both hit the server within milliseconds of each other, and the first one grabs a lock and marks the key in progress. The second one arrives a moment later, sees the lock, and gets immediately rejected. A 4-9 conflict. Not processed, not queued, bounced. Because letting 2 identical requests race each other through a financial ledger is exactly how money gets duplicated. Scenario 3. This is the one that actually impressed me the most. What if we reuse an idempotency key but charge the payload? You send the same key, but this time the amount is $500 instead of $50. Maybe a bug in your code, maybe someone tampering with a request. Stripe hashes the entire request body the first time it sees a key and stores the fingerprint. When the second request comes under the same key, it rehashes it and compares. Mismatch, then it was rejected. So immediately, because a repeated key with a different payload isn't a retry, it's completely different and possibly dangerous request wearing someone else's ID badge. Same key, same payload, replay the cache result, no double charge, two identical request racing, reject the loser, same key, different payload, reject it as fraud shape, not trust it as retry. None of this is visible to you as a developer. You just send a header, but underneath that header is an entire discipline most engineers never get taught in school. Designing for a network that lies to you. So far, we have solved two problems: an API that never breaks, a ledger that never double counts. Both of those matter when money moves from one buyer to one seller. But most of the interesting businesses built on Stripe today aren't that simple. Think about DoorDash. A customer pays once, and the single payment has to split between the restaurant, the driver, DoorDash own cut, instantly, correctly, every time. And that's not a payment anymore, it's a graph. So Stripe's answer to this is called Connect. And the mental model genuinely is elegant. Every account is node, every payment is directed edge. Once you think of it that way, like split this payment 11 times stops being a special case and becomes just a slightly bigger graph. There are two ways to move money through that graph, and which one you pick says a lot about the kind of business you are running. So the first is called the destination charge. A buyer pays the platform, and in the same atomic operation, the money splits. The seller gets their cut, the platform automatically skims its fees off the top. Done. This is the right tool when it's genuinely one buyer paying one seller and you want the money to move immediately. But what about the shopping cart? Right? When items of 5 different sellers, or a hotel booking where you need to hold the money in escrow until checkout day, not the moment of booking. That's the second pattern: separate charges and transfers. The platform takes the entire payment onto the own balance first, like nothing moves yet. Then whenever your business logic decides, after the stay is confirmed, after all the 5 sellers items ship, you fire off individual transfer calls, splitting the money out of your own schedule. Same underlining rails, completely different shape because the business underneath them is different shape. Now, this is the part that Stripe actually stopped being a payment gateway company and actually became something closer to a bank for the internet supply chains. Every platform that adopts Connect isn't just processing the transaction, they are outsourcing an entire category of financial plumbing headaches, KYC, tax reporting, payout timing, dispute liability, all of it gone, replaced by an API call. And once a marketplace is routing its entire seller base through the graph, ask yourself honestly, how do they ever live? Remember the mental model from the start of the video: swallow the complexity internally so the interface stays a straight line. Watch what the strategy builds layer by layer over a decade. Layer 1 is just moving money, commodity, thin margins, the table stakes. Layer 2 is Connect, the marketplace graph we just walked through. And layer 3 is fraud detection running silently on every transaction. Layer 4 is automated billing, tax and revenue accounting. Layer 5 is actual banking infrastructure, corporate cards, working capital loans, sitting on top of every company's own transaction history. And here's the trap most competitors fall into. They'll look at layer 1, see thin margins, and assume Stripe's business is commoditizing, right? It is, of course. Like, that's the point. Stripe was never trying to win one layer, right? Like, layers 1 is the entire job is to get so deeply wired into their infrastructure that adopting layer 2, 3, 4 and 5 isn't even a decision anymore. It's just a path of least resistance. By the time the company is running billing, tax, fraud detection, payouts through Stripe, walking away doesn't mean switch platform providers. It means ripping out accounting, compliance, banking simultaneously. Nobody does that. Nobody can do that without tons of planning. That's not a moat built from marketing, that's actually the moat built from 3 engineering decisions: an API call that refuses to break, a ledger that refuses to double count, a money modeled a graph instead of transaction, compounding for 13 years until living becoming structurally irrational. So the next time someone tells you Stripe won because of great DX, the good developer experience, you can tell them that it's true, but it's wrong layer to admire. That 7 lines of code on the surface are just visible tip of a system engineered to absorb 13 years of complexity so that nothing downstream ever has to feel it, right? That's what I'm going to keep doing on this channel. Not news, not top 5 AI tools this week. I'm going to take one system, a payment engine, a database, a chip, a protocol, pull it apart down to the actual code and actual math and show you why it won. No fluff, no hot takes, no summarizing someone else's blog post. If I say a system works a certain way, I'll show you the request, the response, the code that makes it true. And if that's useful to you, it's only going to get more useful over time. Subscribe if you want to be here for the next one.